Everyone, welcome back. We're going to start working towards implementing damage, and we're going to look at a couple ways to do that, but let's just kind of jump right into it. We're an editor. We're going to come into our C++ classes. The first thing I'm going to do is we're going to make another class of ability, because we're going to come into here into our abilities, and we have a regular ability and a projectile ability. But what I want to do is take this regular ability and create another C++ class derived from it. And this one's going to be called RPG damage ability. And we can put it in here. And what that means is we want our projectile to be doing damage. So in our projectile ability, we're going to come back and say RPG damage ability is who it's going to inherit from. Okay, so we are going to get functionality here by inheriting. So there's really only one thing that's special about the damage ability that we're going to want to share functionality with. So what I'm going to want to do is come into the ability types, and we're going to make another struct. So we'll say use struct, and we'll call this f damage effect info. And inside the damage effect info, we're going to want a key object pointer to an actor, and this is avatar actor. And we're going to set that equal to no pointer by default, and wrap it with a U property. And then we're going to want a T subclass of U gameplay effect, and this will be the damage effect, and we'll set that equal to no pointer. I'll wrap that with the U property. And then we're going to want one T object pointer for a U ability system component. And this is going to be the source ASC, which we'll set to no pointer. Wrap that with the U property. And then we need a T object pointer again for another U ability system component. And this one's going to be the target ASC. And we'll set that equal to no pointer and wrap that with a U property. I changed the resolution here just to make it a little easier to see. The next thing we're going to want is we're going to save a float. And we're going to call that base damage and set that equal to 0.f. Wrap that with a U property. And I don't ever really use it. If we want to capture the ability level, we can do that, but I usually don't. I'll be honest with you. And now that I think about it, if you want to expose all of this to blueprints, that might be a good idea. Blueprint type on this, and then we could say blueprint read write on all of these. That way, if we're inside blueprints, we can make one of these and have it just inside blueprints. That would be nice. So now that I have the damage effect info struct, what I can do is come into the damage ability, make a public section, and we're going to make a void function called capture damage effect info. And this is going to take an actor pointer called target actor, and then a non-const f damage effect info, which we can do a forward declaration on, and we'll do a non-const reference called out info. After I have my public section for that, we're going to make a private section where we're going to host a couple variables. The first variable is going to be a T subclass of U gameplay effect, and this will be called damage effect. Wrap this with a U property, say edit defaults only, categories, custom values, damage effect. And then the next one we're going to make is this is a gas only variable. You have to have gas enabled to get access to this. But it's a insane variable. I love this. It's called an F scalable float. You don't have to include anything because abilities just know about this, right? It's part of gas. So an F scalable float, and we'll call this damage, or we'll call it base damage. Give this a U property, edit defaults only, category is custom values, damage effect. So this F scalable float, I'll show you how it works, but it has the concept. You can just put a raw number in there. You can put a curve table in there and modify it by giving it different levels, etc., etc. It's a really cool thing. So what we're going to do is, now that we have that, we're going to generate a definition for capture damage effect info, and we're just going to do one quick check, and then we can assume the rest of the stuff is valid, in my opinion. I'm going to say if actor pointer avatar actor from info equals get avatar actor from actor info. If that one's valid, I'm just going to assume the ASC is valid and the rest of the stuff's valid. So we're going to say, if that's the case, then we can take the out params, out info, and we can set ability level, and we'll just go in order, and we can do get ability level. It's just built into abilities. And then we can take the out info and the avatar actor. We can set that to the avatar actor from out. And then we'll say out info dot base damage. And then, so we need to say base damage, but it's not a float, so you can't do that. So you have to say dot get value at level. And for the current, what we can do, the only real level concept we have is the ability level, right? So we can just say get ability level. So we're going to scale it. If you have an ability, you can just increase the level of the ability, and then its base damage will go up this way. And then we take the out info, and then the damage effect, set that equal to damage effect, and then the out info dot, we can set the source ASC equal to get ability system component from actor info, and then we'll check if is valid target actor. Then at that point we can say the out info dot target ASC equals U ability system globals get, oh, I need to include that, globals include get ability system component from actor, which is the target actor. Now that I've captured this damage effect information, what I want to do with it is, because the projectile ability has all this now, right? We need to be able to apply the damage. So let's come back onto our projectile right here, and we're going to make a public variable. This needs to be public variable, and it's going to be an F damage effect info, and we'll call this damage effect info. And I'm not going to set any, we'll set some U properties. So we can say U property, blueprint, read, write. That way we can do it inside the blueprints as well if we really wanted to. So now that we have this public variable damage effect info, we can come back real quick into the projectile ability, and in the spawn projectile right here, in where we're spawning it, when we're doing deferred, what we can now do is, after the projectile params, I can just make an F damage effect info called damage effect info, because now I can say capture damage effect info, and we don't have a target actor right now, so we're just going to set it to null point. And then we'll take the damage effect info and we'll fill that in by non-const reference. And then now that I have that, I just take the spawned projectile real quick, and I set its damage effect info equal to damage effect info. So now my projectile has all of this gas information packed into the projectile as it gets shot away. We want that. What we can do after we set the damage effect information is, if we come back to the original spawn actor deferred, we can actually add a third parameter to it right next to it. And we can add the avatar from actor from info. what that is going to set the owner of it. All right, so the owner is going to be from avatar actor from info. And actually, we can just get rid of this function call because the whole point of caching the data is to get rid of function calls. So let's get rid of that. And then, so we're going to set the owner of the projectile as the avatar actor as well. So that means I can come back into the projectile base and, oops, I need to include the ability system types. I didn't include RPG ability types. So what we are going to need, I have the projectile mesh itself, but normally projectiles have a specific collision volume to them, right? They don't have something that's just the representation if that hits it. Usually there's some kind of hitbox to it, right? Or whatever. So we're going to make a T-object pointer, and this can be of a uSphere component, which we will use a forward declaration for, and we'll call this overlap sphere and give it a U property. I can close the damage ability. Now that I can come here, I can say overlaps, overlap sphere equals create default sub object of a uSphere component. And we'll just call this overlap sphere. Get rid of this header that writer auto included for me. So now that I've created this overlap sphere, what do I have in here? I don't have anything, but this is an actor. So because it's an actor, we can just make a protected section. So we can do a virtual void begin play. And now that I have a begin play, I can just call super begin play. And then we only want this to apply a damage effect on the server, right? So the easiest method without getting into complex lag compensation and other features that I don't want to just preemptively jump into, we're just only going to allow this overlap to occur on the server for now. So we're going to check on begin play if has authority. So if the projectile itself has authority, what we can do is take the overlap sphere and we can say on component begin overlap. Now that should sound familiar with blueprints. On component begin overlap. This is just the delegate in C++ for it, but it's a dynamic delegate, so we'll need a dynamic callback. You need a matching signature in your callback, and in order to get that, I never really remember. So if I just click on that and I go to the declaration, it'll bring me to primitive component.h, where I click on that and I go to the declaration of that, and it brings me to the definition line 215 of primitive component where it declares it. So all I have to do is take this. That's a lot. It's a lot. Oh no, I highlighted it wrong. So we'll just take this, we'll copy this, come back into the projectile, and then in the projectile section, I will say protected as well, because I would like child classes. If you want child classes, they can override this or not. So we could say virtual void on sphere begin overlap. And this needs a matching signature, so I just paste it here. But you have to remove all the commas between the type names and the variable names. To declare the delegate, you have to put all the commas in there, but to use it, you got to do that. But because this is going to be a dynamic callback, we do have to wrap it with a U function. Don't need any specifiers. We just generate a definition for this. So now I have this. I'm going to add dynamic. The object is going to be this, and we'll send the address of this class we just fully qualify on sphere begin overlap. And now we have our callback bound for the on component begin overlap only on the server. So any code we write in here will only be executed on the server. So the first thing I want to check is if other actor equals get owner. And if that's the case, return. You don't want to do anything if you overlap yourself. The projectile might hit you and cause you don't know what's going to happen. Don't overlap yourself. And then we can just go into the gas methods of applying a gameplay effect, right? And then destroy the projectile and apply the gameplay effect. So we're going to start trying to gather data. The first thing we're going to say is if U ability system component pointer target ASC equals U ability system globals qualify. Oh, I have to include the header. Qualify get ability system component, and that's going to be from the other actor. Now that I have a target ASC, if I can make it inside this bracket, I want to apply this damage effect. But at the same time, I want to make it so anyone can just apply a damage effect, right? We have this set for blueprints, and we have you able to make one of these in any blueprints. So I'd like to make an easier way for, if you wanted to continue in blueprints, to apply a damage effect kind of in any situation. We're going to come down here to the libraries, and we're going to come into the ability system library, and we are going to make another static function. It'll be a void return, and we'll just call it apply damage effect. Ooh, excuse me. And then it'll take a const f damage effect info by reference called damage effect info, and we'll make this a U function blueprint callable. We'll generate a definition for this. Oh no, generate an inline definition. Don't do that. Generator. Oh, damage. Because the damage info effect is only a variable in the function, we could just forward declare it instead of including the header for it. So we'll do that. And then, yay, generated a real definition. Let's simply just apply this damage effect. Using this damage effect info, let's apply one damage effect. We are going to say f gameplay effect context handle equals damage effect info dot source ASC. We can just call make effect context. And then we should take the context handle and we can add a source object, and the source object can be the damage effect info dot avatar actor. And then we will need an f gameplay effect spec handle, which is called spec handle. And again, we'll take the damage effect info dot source ASC and call make outgoing spec. And the damage effect info has the damage effect in it. The damage effect info doesn't have an effect level per se, but we can use the ability level. It's defaulted to 1. And then we need the context handle. We're going to expand this here relatively soon. I'm going to start and show you the basic ways to handle damage, and then we're going to slowly work up. So this is the most basic version of handling damage. But once I have the spec handle, what I'm going to do is actually check if the damage effect info dot target ASC. Oh, I don't think I can call is valid like this. No, I need to call if is valid damage effect info dot target ASC. Then I can just call damage effect info dot target ASC and apply gameplay effect spec to self, passing the dereference spec handle dot data dot get. I do that, Oh, we can make it a const spec anthem. I do that just because I really want to make sure that the target isn't going to take anything unless this is super valid. I don't want to try to use the damage effect info source ASC to apply it to a target ASC, and then if the target ASC is invalid, that will throw an exception. So I'd rather just ask for the target ASC and then apply a gameplay effect to itself. That is the damage effect. That's how I like to look at it, like this. But now that I have this static function, all I have to do is in the projectile base, we can take the damage effect info, and remember we have to capture the target ASC. We can't, it's null pointer by default, and in the projectile, we launched it with a null pointer. So if I can get the target ASC, we need to set the target ASC, and then after that, we can just say urpg ability system library apply damage effect passing through the damage effect info. And then if that's the case, then we can just call destroy. So before we get to take a look at what this looks like here, I should take the overlap sphere and be a little more specific. So we're going to take the overlap sphere and we're going to set collision enabled, to collision enabled query only. And then we're going to take the overlap sphere and set collision response to all channels to ECR ignore, because we only want the overlap sphere to have one collision channel. Set collision response to channel, and that's ECC pawn. We want to ECR overlap that. Now that I have my collision set up, let's relaunch. Okay, looks like I'm getting some errors actually on this build, so let's take a look here. Syntax missing semicolon. I forgot a semicolon at the end of this. Okay. Gameplay effect is an undeclared identifier. So I need to come up here and class gameplay effect. Let's forward declare that manually. And then ability system component is oh man, how come Writer didn't catch any of this? Ability system component. And then what else do I need? I have actor, I have that. And then let's compile again. All right, now that we're back in the editor, we need to do some things. We need to, this is C++ classes, third person blueprints, ability system, abilities, dynamic projectile ability, and we're going in here. Now I have a damage effect, and we've got base damage and damage effect. So I need a gameplay effect for damage, and then we have this base damage that just has a number, but then do you see it says use curve table? This is going to be fun. Base damage is fun. So damage effect, I would say this is worth a folder, or I can say global. I can just say globals, and I can make a blueprint class in here of a gameplay effect. Call this GE damage. Now that we've made GE damage, we're just going to start here. This is going to be an instant gameplay effect. There's not going to be any components for now, but the modifiers, again, we're going to do this the most basic way I can. We're just going to take health, and we're going to add, and we're going to expand this a little bit. We're going to add the modifier magnitude. Do you see this is also a scalable float? Right? We can do the same thing, use a curve table in here. And again, we will go into more advanced methods, but for now, we're just literally going to say health add -15. And that's all GE damage has to be right now. So we can do that, which means base damage is not going to be taken into account yet. So we're just going to leave that at 0. So let's hit play and see how it goes. Got clients loaded up. I've got enemy loaded up. All right, I forgot I have to hit the 1 key to set the projectile before it does that. But anyway, so now we can do this, and it knocks into him. Because truthfully, the mesh is what's bouncing off him. So what I really need to do is set the collision response to all channels as ignore. So we'll take the projectile mesh, set collision response to all channels to ECR, ignore. And now that I've got it to ignore, I also, the scale of the overlap sphere, now that I think about it, the scale is tiny and the mesh is massive, right? So we could also, we need to make this visible anywhere, and then that requires meta equals allow private access set to true. We could just make this visible anywhere, so that way in blueprints we can edit this. And then the projectile mesh, we're going to do the same thing. We're going to say visible anywhere, meta equals allow private access to true. And then now that I've changed the collision settings just to ignore, and then we're going to be able to edit these in blueprints. Let's recompile. Let's go look at our projectile really quick. In here, let's, open the full blueprint editor. The projectile mesh is the root component, and the overlap sphere is that. We can try just setting 0.3 size on that, and then the overlap sphere, the scale, we could set it to like 5. And then theoretically, the mesh will be a lot smaller inside that. And then we might have our overlaps. So I need to push 1 to give myself the projectile. Okay, there it is. And oh, it goes right through him. I'm sorry for the mess that this has been, but I forgot a few steps. Let's change a couple things. We're going to take the overlap sphere, and we do need to call setup attachment to the get root component so that it actually goes with the root component. Now that we've set it up to the root component, let's recompile. Okay, now that I fumbled through the collision settings and forgetting to actually attach the collision sphere to the projectile, now we're going to hit play, and we're going to come on the server. I'm going to push 1, so I have projectile. Oh, I've got a little show arrow, but we'll see. And now it's hitting the enemy, and his health is going down, right, in the most basic sense. And we can check on the clients to make sure that they can, yep, so the clients can damage them as well. And we can take his health all the way down to 0. So thank you for sticking this out with me. Next episodes are going to get into a little more advanced. I'm going to start moving into more advanced damage applications.